Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick to the end of the problem where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 4 to the power of 14 times 5 to the power of 23. Now 4 here, this is the same thing as 2 squared. So if I replace 4 with 2 squared, I get 2 squared to the power of 14 times 5 to the power of 23. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So in this case, 2 to the power of 2 to the power of 14, that's going to equal 2 to the power of 2 times 14. And 2 times 14 is 28, so now I have 2 to the power of 28 times 5 to the power of 23. Now 28, I'm going to rewrite as 5 plus 23. Now I have this times 5 to the power of 23. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 2 to the power of 5 plus 23, that's going to equal 2 to the power of 5 times 2 to the power of 23. Now I have this times 5 to the power of 23. Now, if I have something in the form a to the power of m times b to the power of m, this is the same thing as a times b to the power of m. So in this case, 2 to the power of 23 times 5 to the power of 23, because these two terms have the same exponent, I can rewrite this as 2 times 5 to the power of 23. So now 2 times 5, that's going to equal 10. So now I have 2 to the power of 5 times 10 to the power of 23. Now 2 to the power of 5, that's simply equal to 32. So I have 32 times 10 to the power of 23. And now 32, I'm going to rewrite as 3.2 times 10 to the power of 1, because I'm going to put this in scientific notation form. So now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 10 to the power of 1 times 10 to the power of 23, that's going to equal 10 to the power of 1 plus 23, which is 10 to the power of 24. So 3.2 times 10 to the power of 24 is our answer. Alright, so I have x to the power of 4 minus 10,000 is equal to 0. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 4, I'm going to rewrite as x to the power of 2 times 2. Now, because this is in the form a to the power of m times n, I can rewrite this as a to the power of m to the power of n. So I'm going to rewrite this as x to the power of 2 to the power of 2 minus 10,000 is equal to 0. Now 10,000, this is the same thing as 100 squared. So now I have x to the power of 2 to the power of 2 minus 100 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is the same thing as a plus b times a minus b. So in this case, a is equal to x squared and b is equal to 100. So I have x squared plus 100 times x squared minus 100 is equal to 0. So now this gives me two equations. I have x squared plus 100 is equal to 0, and I have x squared minus 100 is equal to 0. So let's first solve x squared minus 100 is equal to 0. So the first thing I'm going to do is I'm going to add 100 on both sides. So then these two cancel out. I'm left with x squared is equal to 100. Now I'm going to be taking the square root on both sides. So then these two cancel out, and I'm left with x is equal to plus or minus 10. So this is two solutions to this equation. Now, for our two other solutions, for x squared plus 100 equals 0, I'm going to first start by subtracting 100 on both sides. So then these two cancel out, left with x squared is equal to negative 100. Now I can take the square root on both sides. So then these two cancel out, left with x is equal to square root of negative 100. Well, the square root of negative 100, I can rewrite this as the square root of 100 times the square root of negative 1. And if you guys already know the square root of negative 1, this is equal to the imaginary number I. So now I have x is equal to the square root of 100, I. Now the square root of 100, this is the same thing as plus or minus 10, so I have plus or minus 10i. So now, to list all our solutions, x of 1, this is going to be 10, x of 2, this is going to be negative 10, x of 3 is going to be 10i, and x of 4, this is going to be negative 10i. So these are my four solutions to this equation. So I have 4 to the power of x plus 4 to the power of x plus 3 is equal to 1/3. Now, for this equation, I obviously want to find the value of x. So for my solution here, first start with 4 to the power of x plus 4 to the power of x plus 3 is equal to 1/3. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 4 to the power of x plus 3, we can rewrite as 4 to the power of x times 4 to the power of 3. Now this is equal to 1/3. Now from here, what I'm going to do is I'm going to factor out 4 to the power of x. So now I have 4 to the power of x times, well, 4 to the power of x divided by 4 to the power of x is 1. So I have 4 to the power of x times 1 plus, now 4 to the power of x times 4 to the power of 3 divided by 4 to the power of x, simply just 4 to the power of 3. Now this is equal to 1/3. Now 4 to the power of 3, let's go ahead and find the value of that. Well, 4 to the power of 1, this is equal to 4. And 4 to the power of 2, this is equal to 4 times 4, which is 16. So 4 to the power of 3, this is going to equal 16 times 4, which is 64. So now I have 4 to the power of x times 1 plus 64 is equal to 1/3. Now 1 plus 64, that's equal to 65. So now I have 4 to the power of x times 65 is equal to 1/3. Now I want to isolate x, so I'm going to be dividing both sides by 65. So then these two cancel out, and I'm left with 4 to the power of x is equal to 1/30 divided by 65, which is 2. Now, 4 here, this is the same thing as 2 squared. So if I replace 4 with 2 squared, we get 2 squared to the power of x is equal to 2. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is equal to 2 to the power of 2x. So I have 2 to the power of 2x is equal to 2. Now 2 here, this is the same thing as 2 to the power of 1. If I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2x is equal to 1. Now if I divide both sides by 2, I get x is equal to 1/2. So this is my answer. Now, to go ahead and check, I'm going to plug in 1/2 into my original equation. So I had 4 to the power of x plus 4 to the power of x plus 3 is equal to 1/30. Now I know that x is equal to 1/2, so now I have 4 to the power of 1/2 plus 4 to the power of 1/2 plus 3 is equal to 1/30. Now, 4 to the power of 1/2 plus 3, well, 1/2 plus 3, 2 times 1 is 2, 1 plus 1 is 1, plus 2 times 3 is 6, so I have 1 plus 6, which is 7, so I have 7 over 2. So I have 4 to the power of 1/2 plus 4 to the power of 7 over 2 is equal to 1/30. Now 4 to the power of 1/2, this is the same thing as the square root of 4, which is actually equal to 2. So I have 2 plus, now 4 to the power of 7 over 2. This is the same thing as the square root of 4 to the power of 7. And the square root of 4 to the power of 7, that's going to equal 128. So I have 2 plus 128 is equal to 130. Now 2 plus 128 is 130, so I have 130, which is equal to 130, meaning our solution is right.